Okay, so we're moving on now to section 3 of chapter 18, where we're looking at the series RL, the resistor inductor circuits, and finding the voltage and the phase angles. The key point here is in a series circuit, again, we use current I as the reference. In an RL circuit, voltage leads, so V sub L and X sub L, the reactants, are plotted along the positive axis of the y-axis. The source E, or the impedance Z, is the hypotenuse, and theta is the phase angle. So if we look down here at our diagrams here, we notice first off that we have X sub L in the positive direction, where before we had X sub L in the negative direction for an RC circuit. For an RL circuit, X sub L is in the positive direction. So in going with what that statement says, we have here, if we look at V sub L is 90 degrees ahead of V sub R and I in the phasor. Okay, and notice that the phasor again is rotating counterclockwise, and as it does, V sub L is leading the current by 90 degrees. So if we take a look at an example here, let's let the resistance V sub R be 15 volts, and again we're referring to this little circuit here, simple RL circuit, and the voltage across the inductor equal to 10 volts. So those are our voltage drops across each of those components in the circuit. Calculate the E, the supply voltage, and the angle theta. So starting again with the tangent theta, V sub L over V sub R is equal to 10 volts over 15 volts, and we get a value for tangent theta at 0.667. That's not the angle, that's the tangent of that angle. So to come up with the angle, we need to take the inverse tangent of that number, 0.667, and when we do that on our calculator, we end up with an angle of 33.7, a little over 33.5 degrees. So now again, we have to pick one of our other functions, our trigonometric functions, based on what information we have, and determine if we can solve for the source voltage, now E. So in this case, the best one to choose is the cosine function. Cosine of theta then will equal the V sub R over E. So, and really all we're doing is we're looking at this triangle here. What do we have available? Well, we don't have E, but we do have V sub L, which is the angle adjacent, which forms that leg of the right triangle, and we do have V sub R, which is this angle, or this leg of the triangle. So having these two legs, we can determine which value. So we're looking for E. We have V sub R. We have V sub L, but that's not helpful for us in this portion. So we're going to choose V sub R and the cosine of theta. We're going to use that value that we solved for up here. So V sub R then over cosine theta, when we rearrange the terms, becomes 15 volts divided by the cosine of that angle, 33.7, and we get our applied voltage of 18 volts. And that point right there, we could mark that as the rectangular coordinates of the real and the imaginary. Well, the real part would be the 15 volts, the imaginary would be 10 volts, that would be J 10 volts. So now let's look at another problem where we do have the source voltage, 10 volts, and we do have the V sub L, 5 volts. Again, this value here has changed from 10 volts to 5 volts, and we're given E. So find V sub R. It's not going to be this 15 volts down here because this has changed now. We're just using this for illustration, and the angle theta. So now instead of choosing the tangent of theta, we're going to choose the sine of theta. Why? Because we do know V sub L and we do know E. Those were two of the givens. So 5 volts divided by 10 volts give us a sine of theta of 0.5. And when we take the inverse of that, sine inverse of the inverse sine of theta, 0.5, it gives me an angle of 30 degrees. I had told you before, there are some angles you're going to learn and you won't even need to do your calculator. This is one of the angles that shows up quite a bit in doing analysis and problem solving. The angle 30 degrees, the sine is 0.5. Okay, it's kind of like the values cosine and sine of 45 degrees. They're both the same because the legs project the same ratio onto the axes. So now we can use the tangent of theta, v sub L by v sub R. We're going to move our terms around so that we can solve for the unknown, the voltage drop across the resistor. So we have v sub L over tangent theta. So 5 volts, we're going to take now the tangent of 30 degrees, and we get 8.66 volts. Okay, so seems like a fairly simple problem, and it is. You just have to know which trigonometric function to choose when you're solving for them. So as we move forward then in series circuits, where we're going to start to use the reactance value, x sub L is equal to 2 pi FL, to help us solve for our unknowns.